Next, we will talk about an infinite plane sheet of charge. Now, how do we handle this? So let's say we have a sheet of charge, and we have to find electric field at point P above it, right? So it's going to be above this sheet. Now, how do we do this? Well, first of all, let's cheat a little bit. So why are we cheating? The reason why we're cheating is because we already have the answer for a line of charge. So instead of dividing it into small segments, we are going to divide this infinite plane sheet of charge into long strips. Each long strip is going to have a width dx parallel to y-axis. In my coordinate systems, I have chosen y, z, and x. Okay? So x is coming out. So the area of this portion is going to be L dx. Of each of these volume elements is going to be L dx. 1. That's 1. 2. The charge on each strip, dq, is going to be sigma L dx. Actually, so I'm going to start sigma dA. Why? Because now it is a surface charge density, so we're going to need the area, which is going to be sigma L dx. Okay? Then the charge per unit length is going to be dq over dl, or sigma dx. Okay? Now, number 4, the main reason for using this cheat is so we can use the equation from a long straight wire, which is going to be dE equals 1 over 2 pi epsilon naught dx over r. Okay? So this is the reason why we were cheating. So now each of these strips, if you can imagine, I'm going to try to draw this properly, is going to be this one. So if A is the distance between the sheet and the plane, then this would be R, and I'm just going to call this X, right? The separation. So we can use symmetry arguments to note that the only contribution is going to be from dz. So number 5, the only contribution will be from dz, which is going to be that. So the total E is going to be integration dEz, which is going to be integration. When I can plug this value in here, I will get sigma over 2 pi epsilon naught dx over r sine theta. Okay? Now what is sine theta? Sine theta is A over r. Okay? So this angle is going to be theta. So sine theta is going to be A over r. So I can say sigma over 2 pi epsilon naught dx over r, A over r. And I know r is going to be further equals to, r will be a squared plus x squared. So r squared is that. So I can plug that value in here. So what do I get? E equals sigma over 2 pi epsilon naught dx a over a squared plus x squared. Okay? So I can take things common out, out of the integration. it is going to be sigma over 2 pi epsilon naught a integration over dx divided by a squared plus x squared. Okay? And this integration is going to be from minus infinity to infinity. Okay? And you can look it up that this integration actually, once you solve it, becomes equals to sigma a divided by 2 pi epsilon naught tangent inverse of x over a from minus infinity to infinity divided by 1 over a. So that is what the integration looks like. So a's will go away, and I can plug those values in here. So I'm going to get sigma over 2 pi epsilon naught tangent inverse of infinity minus tangent inverse of minus infinity. Okay? Tangent inverse of infinity is pi over 2. Minus tangent inverse of minus infinity is minus pi over 2. Plug those in, solve it to get sigma over 2 pi epsilon naught times pi. Right? Pi over 2 plus pi over 2 gives you pi. And so your final E comes out to be sigma over 2 epsilon naught. So for an infinite sheet of charge, E will be sigma over 2 epsilon naught.